what layer is on the other side, what network layer is there, and it has to carry the appropriate control message to configure and learn the IP address. The two sites still have IP addresses, so the PPP has to be aware of that, although it doesn't have any of its own addresses. So this is basically the bookkeeping that you need to do. Okay. So that's as much as we're going to talk about PPP. Any questions, anybody? Are you using PPP at home? No. It's quite commonly the link from home is actually is a PPP link. Okay, so the next topic is a broad and a general one, and we're not going to study this in a lot of detail, but there are some important issues here that I want to touch on. Okay, so this is a very big topic, virtualization. Okay, so what does virtualization mean? So Java, you use Java virtual machine? Why is it a virtual machine and not a real machine? So the idea is that when you are trying to work with a lot of detail, you try to abstract it away and offer a generic interface. So the Java virtual machine is essentially giving you a standard computer that you think you're programming. That's the Java, and but the actual implementation could be hairy and it's hidden from you. Okay, so that's the basic idea of virtualization. It's building abstraction so that users at higher levels don't have to worry about the details at lower levels. Okay, so the internet is very virtualized right now. So right now you just use global email addresses, global web addresses. You don't need to know anything about the lower level details, and that was not always the case. Okay, so when let's see, so when a lot of these technologies started, so there were networks were quite old actually, because there were phone networks before there were computers. Okay, so let's say somewhere in the 70s there were networks already, but they had names like, there was an ARPANET, there was Aloha, a packet satellite network, there was a radio network, and there were cable networks. Okay, and they had absolutely nothing to do with each other. Okay? So they used different addressing conventions. There was no IP, a global naming protocol. They had their own formats, their own error recovery, their own routing. Okay, so these networks were not designed to talk to each other. They were independent networks. So there was ARPANET and there was a satellite network. They have nothing to, you couldn't, so let's say if you wanted to send data from one to the other and you had to do something like that, you had to have a special computer that is set up as a gateway between the two networks. So if you want to send data from, let's say this one has XY and over here it's AB, if you send this address in this network has no idea what you're talking about. So the only way you could get across to AB is to send a message to the gateway, and within this message you explain that you want to send a message to AB, and which is completely different, not only the different addresses, but completely different format of addresses. So the gateway will receive the message and copy it to the other side and then send it on the other side. So the email addresses in those days would would look something like, if you wanted to send email to somebody on another network, let's say an IBM. So you would say something like gateway at IBM.ARPA or something like that to get to the gateway. And then there will be like a special convention. You put like a percentage sign or some special thing, and then I'm going to, within that, I want to send it to AB at IBM.bitnet or something like that. So there's no internet right now. Okay, there's ARPANET and there's bitnet. So you send a message to the gateway. You can send that because the gateway is connected to both the networks. Basically telling him, when you get this message, if you see percentage, please forward it to the following network and the following thing. So it was obviously very ugly and inconvenient. So any questions? So that was the real state of the art until I'd say mid-80s or so. There was no universal email addresses. And so that is what is today's internet is also attributed to Cerf and Kahn. Their internet architecture was that everything should be virtualized. There should be inter-network addresses and local network addresses. So we think of as IP addresses and MAC addresses. And this inter-network addresses, they are global. So that's today's IP. And hide everything, what's underneath, cable, satellite, telephone, ATM, whatever it is. Nobody needs to know that. So only the providers and the designers need to know about this, and everybody else just needs to know only about IP. So this started happening in the late 80s and kind of got completed in the 90s. So there are two particular networks that we'll look at today, not in a lot of detail, ATM and MPLS. So they're both separate network technologies in their own right. And but today, ATM, let's talk about MPLS later. ATM is, even though it's a whole technology, today it's used as a link layer technology in today's IP-based internet. Okay. So I'm going to skip a lot of things here. We've discussed this already, that ATM was meant to be an integrated end-to-end transport for carrying voice, video, data. It's based on connections, and there's much better support for quality of service and so on in ATM. Okay. Right, so we've discussed most of these based on telephony, uses packet switching, using virtual circuit, the fixed length packets called cells, which are actually quite small. Okay. And we're going to skip over a lot of this, the ATM architecture, what the layers there are, what is the equivalent of network and link layer in ATM, and the various descriptions of the layers within. You can provide different quality of services in ATM. Can be constant bitrate, variable bitrate, which is higher level services, and then for the regular IP type services also. So we've seen this table already. Right, so it's an interesting story here that the ATM cell is 48 bytes, and that's kind of an odd number. And apparently there were two groups fighting for the cell size. One group was stuck on 32, other group was stuck on 64. They could not agree. So finally the compromise was that to keep everybody unhappy and make the payload size 48 bytes, which is still the case today. Okay. Not Okay, so quickly, what is ATM's role today? So what I'm doing is trying to use ATM as a black box for this